Okay, so hello everybody and welcome to our course. Now, this is, we're living in unusual times, and this is quite unusual to start the course, this way, working remotely and from homes. We'll try to do our best to make it interesting and entertaining and to get as much feedback as possible from you guys, but bear with us. It might make some time for us to tune up and learn how to use all the technology and make it the most optimal way. Now, feel free to let us know, to give us feedback. In fact, we'll be doing lots of polls to actually understand how things going. All right. Now, this is the first time offering of this course in the Smagolega Data Science for Business course. So we are also putting together information as we go, and there are certain plans, there are certain things we want to do during this class, but it also will depend on how fast we're going. It will depend on your background. We'll see how easy or how challenging the material is, the one that we're giving to you, and also what we need to adjust to make it work well in this remote setting. But this is the first lecture. The course is Data Science for Business, and this is Introduction to Data Science lecture. All right, so let's get started. Now, if you course Technicalities, so we're gonna have lectures, we're gonna hold lectures here on Fridays, 6:10 to 7:30, and we're planning to have probably 10 lectures. And I will also try to keep all of them on the same ID. And by the way, again, guys, please, whoever has their mics on, please keep them off. We are recording all this. Now, seminars, we'll have seminar on a different Zoom ID that's going to be happening after the lectures. Now, seminar is going to be even more challenging because that's where we want more interaction. And so we'll be thinking about the ways making them interactive. If you have ideas and suggestions, please, tell us. Now I'm looking at, please guys, keep your mics off, okay? Now we have a club website, class website, and here is the link to it. And we're going to be updating information and putting links over there. And then there is also Wiki for the seminar pages. We have a Telegram group, and I think pretty much all of you who are here, you are part of the Telegram group. So you know what's going on there, and we're going to use that Telegram channel, Telegram group as a main way to interact with you. And guys, we're going to monitor it. And for the software for this course, we're going to use RAPIDMINER. Now, I'm going to talk about it a little bit more in a few minutes. First of all, let us introduce ourselves. So my name is Leonid Zhukov, and I'm going to be teaching this course. I'm professor in computer science department, have been with High School of Economics for 10 years. I'm also a partner at Boston Consulting Group, and I'm leading their data science, advanced data science team. And so a lot of things I'm going to be talking about, and a lot of ways we look at the business problems. This is a mixture of academic and industry experience. We also have Anvar Kumukov, who is going to be helping us and who's going to be leading the seminars. And I don't know, Anvar, are you here?
Yep, I'm.
Okay, say a few words about yourself. Introduce yourself, please.
So basically, I'm a PhD student of the Leonid, and I'm studying computer science and machine learning for the last 5 or 6 years. I've got my bachelor degree from the HSC and then a master degree, and now I'm studying in the PhD, so getting my PhD.
Thank you. So Anvar was going to be leading all of their seminar work. And we also have Ilya Makarov. Ilya, are you with us? Hello? Ilya Andreevich. Okay. Ilya Makarov will be helping us also with seminars and lectures, and will be helping us in general to run this course smoothly. So this is us. Unfortunately, we cannot just be with you guys in the same room, but I do hope that maybe, by the end of this course, we will still be able to get together in one auditorium and actually have this lecture live. We'll see how it goes. All right, so now about the class, about you. We actually put together a short questionnaire to just understand where you guys coming from. And, we got like 80 to 85 respondents. So, there is 20% of people from computer science. There is what, 33%, business and management. And there is also around 30% from economics. So there is a, sort of big mix of knowledge, experience. And as always with Mago Lego course, there is always a sort of balance we want to keep in between, the difficulty, sort of computational difficulty, programming difficulty, technical difficulties, and your knowledge and experience. And for some of you, it's going to be more challenging to actually, to build models. For others, will be more challenging to actually evaluate business impact. Now, second question we ask is how much experience do you have with the programming? I was actually very surprised and impressed to see that in spite of the fact that you guys coming with so many different backgrounds, there is, 66% experience with Python, right? If I knew that before, we would, maybe we would take Python as a language, but honestly, there are other reasons why we wanted to teach you using RAPIDMINER, and I'm going to explain it in a minute. Now, having said that, if you are a big Python fan and you enjoy it and you're capable of writing code fast, feel free to use Python, or within RAPIDMINER there is a way to integrate Python in. So ultimately, what we are after are the results and not necessarily exactly the code that you're going to be writing. Finally, we ask you about if you have any data science experience, any classes in data science. Again, 45% yes. So it's like half people have data science experience, half do not have. So which makes, again, our job much more difficult, because now all of a sudden, I need to make sure that I don't talk and explain just complete basics, because that's not going to be interesting for 45% of the people who already had data science courses. At the same time, we need to explain basics for people who never had this type of course before. So now you know a little bit about yourself and you know about our challenges. So that's what we're gonna work on, and this is our team. Now, textbooks. Well, I would say, again, we're looking at the different kind of books that can be helpful in this course, and this course is really data science for business. So I'm going to be emphasizing many times that this course is not about teaching you how to program. This course is about how to teach you how to use your mathematical knowledge, your data analysis skills to solve business problems, right? And so that's why the book that I would recommend you and for reading, and I mean, this is a great book. It's called Data Science for Business, written by NYU professors, Foster Provost and Tom Fawcett. The book should be available in PDF. Now, the second book that here is, Data Science. This is a book that is recommended by RAPIDMINER website, and in fact, it does have a lot of tutorials and descriptions on how to use RAPIDMINER. So this is, I would think about this book as a bit of sort of a manual for how to work with, with RAPIDMINER and with the tools. Finally, the third book by Eric Siegel. This is actually a very well-known book among, sort of data science professionals, analytics professional. It's actually just a good reading, right? So you're not going to learn techniques from it, but you're going to learn to understand, the data science problem setups. Okay, now RapidMiner. At the moment when I took a screenshot, and this was during the day today, it's only half of you guys who downloaded RapidMiner. So please, download, install it, because the next hour of the seminar, this is going to be about RapidMiner. Now, why did we decide to use in this course RapidMiner modeling software? Well, there are several reasons. One of the main reasons is because this course is not about programming, right? This course is about building models and solving business problems with those models. So we don't want to spend time on debugging code or getting stuck on sort of one procedure or explaining procedures in code writing. And so in this sense, RapidMiner and this data flow modeling simplifies things a lot. The second big point is, in fact, if you look at the way software has been developing, 30 years ago, everybody was using C and C++, which was quite complex language, very extremely powerful, extremely flexible. Then things start moving along, and Java came along, and people start switching there. Though, for example, Java is not as powerful, it's not as flexible as C++, but it does take care about other things that in C++ you cannot do, and so it's actually much harder to support code in C++ than in Java. Then Java moved to the side, and now data scientists use a lot of Python. And again, this is sort of, we're going more and more from low-level languages to high-level procedures languages. And so the natural sort of step is actually going away completely from writing codes and going into putting together blocks and connecting them. And so the idea of this data flow approach is that from left to right, you have the data flowing from input and through different processing steps. It's also sometimes called a workflow approach, and it's quite logical. In fact, if you write, for example, in Python, you would notice that it's procedure language, you call one procedure after another, and you pass the data from one procedure into another. And that's pretty much what's happening here, except for you don't really need to write procedures, you just connect ports of these blocks. Now, RapidMiner has lots and lots of blocks in it. And so pretty much, all the methods you ever need are in there. Now, if there are methods that are not there, it also has a functionality to allow you to build them. So you can actually take either R code or Python code and wrap it into and put it into the module and then connect the module in. So there's lots of flexibility in that sense. Now, having said that, there is still a steep learning curve because especially if you've never done this type of data flow programming, it will take some time to learn how it works. But after that, it's going to be extremely fast to deal with it. RapidMiner is not the only software out there in the market that allows us to do this. There is Alteryx that is actually widely used by businesses. And there are a couple other things. RapidMiner, we selected RapidMiner mostly because of its of educational license and wide adoption at universities and in community. So give it a try. But again, if you want, you can write in R or Python. Just be aware that a lot of things that you can do in RapidMiner very quickly, it will take quite a long time to do in Python and R. Plus, as I said before, the main goal of this course is to teach you how to use it to solve business problems. And solving business problems really means experimenting with your software, experimenting with results. So the software, the program is really not a goal, it's a mean to answer the question. And so you don't want to spend all your time on writing and debugging code. You would rather spend it on working with solving business problems and trying different scenarios. Guys, please, somebody has mic on, please turn it off. Please mute it, okay? All right. So course schedules. So what are we gonna do? We tried, guys, please turn off the mics. Whoever has it on, please turn it off. So this is a course schedule. So there are several lecture topics, and then there are corresponding seminars and exercises. So we start today with this introduction to data science. This is a very, very high level discussion. We're going to just talk a little bit about the course and talk about a little bit about what data science is and what it isn't. Next week, next lecture is going to be about exploratory data analysis, and we're going to look into when you have data, how to actually explore it, what to look for, and how to deal with this. And then we're going to talk more about predictive analytics and actually machine learning. Right? We're going to look at the different types of machine learning. And then what we're going to do, this course is really use case based. And so what we're going to do is we're going to consider the different business use cases. And for each of business use case will help us to discover certain type of data science, mathematical, machine learning models and methods that will allow us to use them and solve this use case. So there are several use cases that we selected. We might add, remove one. We'll see how we're going to go. We'll see how it goes. We'll see how much challenge this is. But these are all sort of real life use cases that are in quite a demand in business. We're going to use data that comes from either Kaggle competitions or other sanitized open source data. So, we should be able to freely work with it. So one case one would be about retail pricing. And we're going to learn regression modeling. When we talk about retail pricing, we're going to try to predict certain prices. Second case study is churn modeling, where we're going to predict customer churn and build models for that. And that corresponds, we're going to use classification methods to do it. The third study is about customer segmentation, where we would like to find natural groupings for customers. And that's a very typical problem in today's marketing. And we're going to use clustering to solve this. We're going to talk about, next case study is about personalization. That is, as example for personalization, we're going to develop a simple recommender system, where that would be suggesting based on the purchasing pattern, we'll be suggesting items to buy. And then there are two use cases. We're going to decide which one we're going to take, depending again on how much time we have and how fast we're going to go. The use case on fraud detection, which is looking for anomalies in the data, which is obviously very, very important case for an application for insurance and banking. And finally, demand forecasting, right? So, retail is dead without demand forecasting. And we're going to talk about ways and methods of doing it, and doing it slightly different from what typical econometric approach is, where you just look at the time series and run like ARIMAs. We're going to talk about machine learning's ways to do it. For example, as of today, this is one of the most powerful ways to do those type of forecasts. And the sort of smooth ARIMA approach, for example, cannot handle drastic changes in the market behavior like what we're seeing now. And finally, one lecture, the last lecture I want to dedicate to actually talking about the impacting the business, how your solutions can impact the business, how you can sort of sell yourself to the business, sell your skills to the business, and how within the business you can help solving problems. Now, of course, we cannot ignore sort of what's happening right now, all the situation with the COVID. And so, we're going to be using current COVID data in some of the exercises, in particular to do exploratory data analysis. I hope that will sort of help you better understand not only the way to learn, not only the way to manage data, manipulate the data, not only learn RAPIDMINER, but also kind of you learn more about what's happening in the world and what's happening right now with the disease. So that's the plan. Again, this is the first time we are teaching this course, so we're going to be most likely we're going to be adjusting things as we go, and that's why we actually need your feedback. We'll be taking polls but please feel free to give us feedback, either personally through emails or through the Telegram. Okay, so now switching to actual, topic of the lecture, data science. And, for those of you, well, some of you might remember, those times, but that was, it feels like it was not long ago, but in fact, it was 8 years ago when Harvard Business Review came out with this title. It says, "Data Scientist, the Sexiest Job of the 21st Century." And the article was co-authored by DJ Patil. Back then he was at LinkedIn, and they created the first data science group. People didn't know what data science is, actually haven't thought about it, though, data science is not very different, let's say, from old trustworthy discipline of data mining. But that was, that became something new, and data science was defined as a discipline that sits on this intersection of mathematics, statistics, of computer science, IT, and deep domain business knowledge, right? And so, you do need to understand how algorithms work. In general, you have to be somewhat savvy with, computer science and computer architecture, so you can actually implement certain algorithms. But the key here is you need to understand, need to be able to answer the question, why? Why do you want to do this? Sort of, what is this in this algorithm infamy, and how this algorithm can be used. Now, in fact, in this course, we will probably be looking more on the intersection, this sort of mathematics, statistics, machine learning, and business side of the things. We're not going to be working with scalability of algorithms, and in fact, we're not going to be looking very deep into the algorithms, but what's important for us is to understand which algorithms are good at solving what type of problems, and what kind of parameters you can use to control those algorithms, right? So that is going to be our focus. Now, if you look at today's business world, there are probably like sort of 3 types of people in industry that work a lot with data. So, and these are, typical titles that you will see at recruiting sites, and, you will see in business. There are traditional data analysts, and that's where we're usually talking about, business analysts or people who, help business to generate reports and to understand the business performance. And this is usually sort of done on a quite sort of global data level. Then there are data engineers. These are the people who help handling data, and in fact, large data sets. Like sort of the biggest skill for data engineers is to be able to, extract data, transform data, give to data analysts and data scientists access to the data. And finally, there is data scientists, right? There is a subtle difference. Typically, data scientists, they have a bit more of knowledge in machine learning, a little bit more knowledge in and understanding, about software engineering, and so they can actually build models that can be scalable, and that can solve, with machine learning, certain problems. Again, data analyst, BI, is a little bit more about, visualizing data and, getting insight, sort of looking into the past, versus data science is usually somewhat looking into the future. So having said that, these are all people that work with data, and a lot of skill sets that these people have, they're overlapping. In fact, quite often data engineers are good data scientists are good engineers. Today there is, for example, there is a new specialty that becomes quite popular, which is called machine learning engineer. So these are guys who are actually good at scaling machine learning code and putting it into production. Now, if you look deeper, those type of people, they differ by, the skill set and the depth of the skills, the depth of business understanding versus machine learning skills versus sort of hardcore mathematics. versus software engineering skills. Again, you know, there is a sort of wide range of backgrounds and wide range of skills, and all of them today comes sort of under the umbrella of data science. I guess, you know, it's important to understand overall the process that data scientists and data science is going through when we try to approach business problems, right? So typically we start with understanding of business problem. And you know, it's very hard in real life. You know, when you're working in business, it's very hard to do on your own. There are always people who were there before you. There is like business owners, and so what you do is you spend time with them trying to understand what is the business problem they're trying to solve. For example, you know, the company losing revenue, or you know, the costs are too high, or the customers leaving. So that's sort of the business problem. The second step is taking that business problem, trying to come up with analytical formulation. So trying to formulate it as a mathematical problem that can be solved. Like, for example, you know, the business problem can be that customers are leaving, right? So the analytical formulation would be, okay, well, look, is it going to be helpful if we, for example, can predict that the customer is going to leave, right? Will it be helpful for business? And if the answer is yes, and the business can react and do something about it, then maybe we can formulate this problem as a churn modeling. So we can try to predict the probability that the customer is going to leave the business within the next month, and then the business can do something about it. All right? So next step is actually looking for algorithmic solution. So now let's say we have a churn problem formulation. So we know that we want to predict that the customer is going to churn within a month. All right, so how can we do this? How can we solve it? To solve it, for example, we can think about, you know, logistic regression, and we can try to calculate the probability of a customer leaving based on certain features or attributes. For example, we can see you know, customer activity. If, let's say, if it's a bank, you know, the transactions, job history. We can also look at you know, some of like whether gender, age, etc., etc. Or we can also look at the external factors. We can take that all and put into the model and try to predict the probability of the person leaving based on that historical data, and also based on the list of the people who already left or stayed with the bank for a while. So you actually know how, sort of, you can learn how to distinguish in between those who want to leave and who want to stay. That's algorithmic solution. So after you solve it in the sense of, you know what algorithm to work on, then you can actually try to build proof of concept, which is what, you know, mostly in this course we'll be doing, right? We're going to be looking into building the proof of concepts, which is, okay, we're going to be taking data and we're going to be, you know, writing models and trying to predict, you know, solve these algorithmic problems using historical data, right? Then typically, if you were working for a business, the next step would be take this proof of concept and productize it, being minimum viable product, or MVP solution. Now, MVP just really stands for a product with a minimum number of features. It stands for like product that is still useful to the business, but has a minimum number of features. For example, you know, in this case, we should be able to build a model, deploy the model that is connected to all the databases and, you know, collects all the data and returns to the user the probability that particular customer gonna leave the bank, for example, right? And you can think about, you know, various scenarios of the usage of this type of a modeling. You know, it can be, you know, run it once a night, once a week, go through all the customers, rank them by the probability of leaving, etc., etc., etc. So there is like a lot of things we can actually try to do to connect this product with actual business owner and with their needs. And then finally, when this product is created, you put it into use, but that means, you know, change management here really means helping business to start using this product. Because now when you have this product, you need to create for, you know, people who are there, for business people, you're pretty much creating a new way of interacting with the customers, because you're giving a tool that will tell business, that can help business to predict that somebody's going to leave. Okay, now first you need to set up procedures for somebody to own this tool, right, to run it, and then what are you going to do based on the results. So that's sort of a long path, and honestly, though, for us as a data scientist, the most interesting is really in you know, analytical formulation, algorithmic solution building, proof of concept. You know, business sees the effect and the result only when the problem when things are integrated with business. And so it takes time and effort, and it takes sort of a lot of business skills to make this work in the real world. So that's the data science business process. Now, before we switch on to the next kind of mini topic here, any questions?
I have a question. What difference between proof of concept and minimal available product steps?
Right. So typically, I mean, the way we think about this is a proof of concept. It's the user of a proof of concept is a data scientist. So it is like, you know, you build it for yourself, right? You know, you tried that algorithm works. Product MVP, the user is going to be already an end user. So it's a business owner, which means instantly that, you know, proof of concept can work, for example, with historical data. MVP should already have access to the real data and should have a, you know, normal sort of interface. So it should be a web app, if you wish. Does this make sense?
Yeah, thank you.
Anything else, guys? Okay, moving on. So methods, there are very many methods one can use in data science, right? So one of them, and that's would be the focus of our lectures, that's what we're going to be talking about. This is predictive modeling, machine learning, sort of data mining. That's our focus. That's what we're going to do in our lectures. Though this is not the only tools, not the only instrument that you know, data scientists are using. In fact, there are a lot of need in operations research and optimization. You know, it happens that typically in the university, this is a very different sort of specialty that learns linear programming. But in real life and business, you do need to know that. And, you know, hopefully this is a skill set that you will be developing, you know, not in this course, but somewhere else. Then there are other methods that are helpful. This is, for example, agent-based modeling and simulations. There are quite a few problems out there that are too complex to solve using just sort of, you know, equations, or even machine learning is not capable of, you know, working on handling that. Or sometimes, you know, some problems are just better handled in simulations. Like, for example, you want to, you know, simulate traffic jams, or you want to simulate how cars go through intersection, and, you know, the intermission, either the switching time of traffic light is going to be very hard to actually write a machine learning program to solve it, but it can be easily done with agent-based modeling. Or, you know, calculating queues is also, you know, you can try to write formulas. That's one way. Another way is to actually just do simulation. Finally, there is a very special part, which is also very important for business. This is a geoanalytics. So guys who actually work well with geodata, and there's a lot of sort of specific knowledge you need to have in specific software you need to know about to work with geodata. Though again, on the simplest level, we can all do it. Text mining, text analytics, in fact, we're kind of thinking about putting it into this course, but then we decided to sort of stay away a little bit from it because, you know, it's on one hand, it's quite common knowledge, and there are a lot of ready-made software that allows you to do sentiment analysis, for example, or, you know, analyze text for any other information. So this is not very often the core to the business, though it is definitely sort of a skill set, and understanding of how to use that in business is valuable. The same thing goes with computer vision or image recognition. Again, there are certain very specific algorithms, and today with advances in deep learning, this problem has had tremendous success and changes in the last several years. It's quite challenging technically to do. And again, this is for most of the businesses, this is a sort of prepackaged solution that you can buy and use it in your business instead of developing your own. At the same time, churn modeling has to be so closely integrated into your business processes that most of the businesses, trying or still choosing to build those type of models themselves. Okay, so these are methods, and again, as I said, we're going to be focusing on predictive modeling, machine learning, data mining side of things in this course. Now, there was really like sort of three major reasons why one want to use machine learning, in general in business. So one thing is try to detect certain type of behavior or certain type of problems. You want to be able to detect fraud, which is unusual behavior, or you want to be able to predict that, I don't know, equipment is going to fail, the engine on the airplane can fail, so you want to detect abnormal behavior, or patient in the hospital. Predict, obviously, you want to be able to predict certain events. You want to be able that, for example, a customer is going to churn out. You want to be able to predict other things. Now, when we say predict, it's not necessarily going and looking into the future, though that's, of course, big part of predictions. But it also allows us to fill in sort of empty spots within the data. So prediction is not necessarily looking into the future. For example, I have a data and I want to predict price elasticity which means if I change price, how much demand is going to change, right? This is not looking into the future. This is actually just trying to understand the dependency. And third very important point is explanation, explainability. Quite often today, there is this trade-off you need to make in between the quality of predictions and the explainability of the model. So you can build very complex models that are actually quite precise, but they cannot explain why they made certain decisions. On the other hand, there might be much more simpler models that can very well explain, where you're looking at the model, you can understand why it made certain predictions. Say, if you use linear regression, logistic regression, it's very easy to explain the effect of each feature. When you use much more complex models, it's becoming more complicated, though right now there are methods that are being invented that help us to do this. But still, if you're trying to build a model for doctors working in an emergency room, they won't understand why the model says you need to do A, B, and C. At the same time, if you're building maybe a self-driving car, you really don't need to, you don't want the model every second to explain why it goes a little bit faster or it turns a little bit to the left, a little bit to the right. But in any case, whatever you use your machine learning for, whether it is detect, predict, explain, the ultimate goal is really eventually to either optimize the process or improve. And that's something that you need to always keep in mind, that the goal of the exercise is not just to look into the data and being able to detect patterns. The goal is to later on to either improve product or improve process or improve service. So ultimately it's about optimization and improvement that for businesses will be expressed either as revenue increase or cost cutting. Now, here is a very, very simple example, just to put this notion in perspective. Now, if you think, let's think we have some process, let's, for example, for a second, switch to some sort of engineering process. And then there is certain, we're looking at the left column here on the slide. There is input and there is output. And we have three measurements, right? That's all we have, right? There is a particular value of input and that was output. For example, that, the input is, the current, the turn of the knob, and the output is the pressure that the system produces, all right? So and the question that might be asked is, okay, so, what value of input should I put to maximize my output, right? This is a very valid question. Of course, you can try turning things around, but let's say it's quite expensive anytime to do this. I just gave you example, some sort of silly example, but if you think about this, you can have a, say in metallurgy, you have the huge process and, adding certain additives change the purity of the metal you produce at the very end. It might take 24 hours for you to detect the purity, and you literally, depending on this sort of input parameter, you can gain or lose $100,000 per day, right? And so the experiments is not often, it's not something you can always do. So let's say you have this input and you have those outputs. You have 3 data points, and the question is, what would be the optimal input? To answer this question, first, we want to predict, right? We want to learn, based on those 3 data points, the dependency in between our input and output. And in this case, I draw that curve, smooth, nice curve. We're going to talk about, how to select the right curve. Maybe the right thing here to actually just connect those dots with straight lines, or maybe the right thing here to just draw a straight line through all of them, that there is no minimum maximum, or maybe the right thing here is this curve that has a maximum, the one that I'm showing here, and that's what comes from your business knowledge and understanding with the process. But let's say this is a curve, and that's the outcome of the prediction algorithm. So then the next step for sort of business insight, for actionable insight, is really taking this curve and finding its maximum. Now, when we have the curve, we can find the maximum and we can return the optimal input parameter that will give us maximum output of the system. So this is what what I'm talking about when I say, data science is really science that helps extract value from data for business, right? So you have data, you have business, and data science is what helps to extract that value from data. Okay, so this is one of the sort of interesting parts, business use cases. There are plenty of business use cases, and we're going to talk about some of them in more details, but this is a slide I want to stay on for a little bit and just go through them. So if you notice, the use cases that we have here in the frame, consumer goods, telecoms, and banking FI, these are mostly use cases that deals with customers. So this is a B2C use cases. And in fact, in this course, we will be focusing on those use cases. The reason is that, there are several reasons. Well, first of all, you really don't need to have a lot of, deep industry knowledge to understand, for example, how you select, how do you choose, an item when you're buying, the item you're buying in the store, or, what personalization means. It is much harder to understand if you think about, energy, I don't know, how the oil processing plant works, right? You need to actually have those knowledge. Second reason is the data for the B2C type of businesses is much more widely available. And so we can actually experiment. And third, when you go out and get your jobs, most likely you'll be working in, one of those 3 sectors. Now, having said that, eventually we'll probably, maybe, in this course, we'll introduce one lecture for for industrial data science, or maybe we'll have a different course for this. But anyway, so if we look at the use cases, consumer goods, well, the killer use case for consumer goods is, of course, demand forecast, because, without having good demand, pretty much, stores will go bankrupt and manufacturers will go bankrupt. And in fact, right now with this very volatile time, good demand forecast is what will differentiate winners versus losers in the consumer goods space. Second, very important and very popular topic is marketing personalization. This is, as I said before, this is really about giving the right offer to the right customer. And some people would want a discount, some people don't care at all about discount, some people want discount on a certain type, on a certain topic. And so this is about, creating good recommendation systems, like, for example, Amazon and Netflix has. Pricing and promo effectiveness, this is about setting up optimal prices, because clearly, there is always sort of supply-demand story, and there's always you increase the price, you'll drop the demand, right? And so there is always, sort of an optimal price for which you make largest margin, largest profit. And so that can be computed. And promo effectiveness is, you can try to give discounts. Again, when you're giving discounts to customers, some customers buy with discount, but if you give the discount to the customers who would buy even without discount, you kind of wasted that discount, right? And so the question is how effective your promo, if you're doing it in the right time, in the right place to the right customers. Assortment optimization is yet another problem within consumer goods, where you're trying to optimize to put the right items in the right stores. Because the typical problem with consumer goods with the stores is it's either not enough stuff that people want to buy, or stuff on the shelves that nobody wants to buy, right? And in the storage. And so optimizing, putting the right assortment in the right store based on the purchasing patterns, this is a very important problem. And so that's something data scientists deal with. And finally, cross-sell and upsell. This is what you can also offer to the customer when they're buying. So it's sort of market basket analysis, what you else can offer to the customer when they're buying certain items, either from the same type of category or other categories. So these are all type of business problems, very, very popular business problems. And as a data scientist, you should be able to, well, solve them, or at least you should be able to understand how you can formulate each of those business problem as analytical problem, and eventually how to solve this analytical problem, right? Telecoms, here, so what differentiates, telecoms and banking versus, say, consumer goods? Well, aside from that's completely different industry, it's the fact that the customer, and what in common in between telecom and banking, is that acquiring customers is expensive, right? There is a competition, and so it's actually hard to get a customer. And there is a competition, and you need to and the customer should have certain credit history. So customers costs, right? And that's why those type of industries, they're actually concerned about predicting that customer is going to leave, and that gives us this churn modeling or retention modeling that becomes a very important problem for those industries, and they get ready to put money into it. Next best offer. This is something what sort of offer you can give to you, particularly based on the usage. For example, whether offer you cheaper connections or cheaper connections within the same mobile operator phones, or whatever next offer we can give you. And then there are some problems, of course, that are related to operations of telecoms, like network optimization, the right positioning of the network towers, the right location of the stores, et cetera, and all the infrastructure problems. And that's where actually operations research and geosciences are very important. In banking, it's, of course, the classic problem in banking is credit risk assessment, right? Sort of computing credit score for customers, and also trying to, not only predict churn, but trying to predict if the customer is gonna, return the credit you're giving to the customer, right? Or it's gonna be failing. Fraud detection, also quite a big problem for banking and FI. Customer claim management, automation of that management. So these are typical problems. And again, in this course, if you now go back in this lecture and look at the topics that we're going to cover, use cases, they're all pretty much coming from this part of the screen. Now, just for completeness, if I look at two other industries, industrial good and energy, and in fact, in Russia, these are, sort of the fundamental, these are the industries that keeps our country running. In industrial goods, it's first of all, it's process optimization. So how you're going to optimize the processes to provide maximum output. It's also predictive maintenance. It is about predicting when the equipment is going to fail. And if you want to build a parallel in between this and other use cases, like sort of churn managing, prediction when somebody's going to churn out, and predicting when the equipment is going to fail, these are kind of similar problems. You try to compute, time to event, or the possibility of event in the future. In industrial goods, of course, demand and supply forecast, you also need to understand how much things going to cost and how much your raw materials cost. Now, sometimes, like right now in energy, of course, all the forecasts couldn't come up. I mean, there's no forecast a year ago that could predict what's, for example, happening with oil prices. But in the less volatile times, of course, having good demand forecast and supply forecast is quite important. And if I look at the energy, since we start talking about it, is of course production optimization, because everyone wants to spend less money and produce as much oil as possible or as much electricity as possible. Logistics is quite important in energy because, again, if it's talking about oil and gas, like oil platforms and the places where they produce oil, they're usually in quite remote locations. Typical energy projects, they're actually very, very capital intensive projects that cost millions, hundreds of millions of dollars, actually billions of dollars to build factories and to build oil platforms. And so it's very important to manage the risk. And what's also becoming very, very interesting and popular and important is robotics and automation on the platform. So it's literally unmanned platforms, unmanned plant. So that's about industrial data science. Again, this course, we're going to talk about more consumer goods, telecom, and banking, right? We're going to talk about those use cases that are sort of we're used to, that we see in real life, that we can reflect, and that's which do not require intrinsic and deep knowledge of each and every industry. So, switching a little bit and going a little bit deeper into the topic, the topic of machine learning. In general, there are like really three classes of machine learning. I mean, there are probably more, but in the big picture, iBird view is really three classes. There is a class of unsupervised learning, machine learning, unsupervised learning, which is trying to find a structure within the data, right? So we do not have any examples. We just have a bunch of data points, and we're trying to see if some of them are next to each other, or others are far away from those. An example is I'll give you a bunch of, say, mixture of fruits and vegetables, and I'm going to tell you what's fruit and what's vegetable, and what different types of vegetables. I'm not going to give you examples, but I'll try to ask you to sort them out and put together those groups that look similar, right? And based on the features you're going to use, you can probably put elongated vegetables together, and the fruits that oranges and apples together, etc., etc. So that's unsupervised learning. So ways to find any patterns within the data, and the patterns you really don't know what they are. Second is supervised learning. This is a learning, another way, it's learning with the teacher, learning by examples. When you're given examples, and then, or the system is given an example, and then the system can learn from those examples. And probably one of the most famous examples these days is, say, Google, or right now it's pretty much all internet companies allows you to upload, I don't know, cats and dogs, and then they can sort and distinguish, give a picture, and it will tell you if it's a cat or a dog. This one is really the working horse, if you wish, of data science, right? So most of the problems that we're working on, they will be solved by supervised learning. So where you have examples of something, and then based on those examples, you can predict things. For example, you have sample of people who churn out, and then you have people who are very happy with the service, and then you can actually learn the differences between those groups, and automatically when the new person comes in, you can sort it or differentiate it, put it into one group or another. And that type of problems, they exist all over the place in business. And in fact, the other reason the supervised learning is very popular is because it allows you to easily check the quality of the solution, right? Because you know what to expect, and we're going to talk actually, we're going to talk a lot about how you measure the quality of the solutions in the later lectures. But supervised learning gives you a very clear way to measure the quality of your algorithm. Unsupervised learning is a little bit sort of murky in the sense that you're looking for a grouping of the data, You know, there is no ultimate truth. There is no sort of right and wrong there. There is one grouping then better than the other. But it's very hard to kind of pinpoint a good number. Finally, there is reinforcement learning. Well, this is learning with sort of confirmation where, and this learning is usually used on sort of on agents where, you know, the agent does certain actions and the system will either say it's good or bad. This is how you know, train system to learn and win, you know, in chess or checkers or whatever game, computer games. That's what you also try, that's what also people try to use in self-driving cars. Now, unfortunately, today there is really no good use or easy use for that, for the reinforcement learning in real life and real business applications. One of the reasons for that, reinforcement learning takes really long time to learn because, you know, it's just literally the only information you get from the user is sort of thumbs up, thumbs down, yes or no, as a reward. And typically in business, you just don't have that much data. While if you have computer games, you know, you can generate as much, you know, data as you want in this virtual world. You can make computers play with each other, and sort of that gives you data to train the reinforcement learning. At the same time, if you think about AI, right, as creating systems that are, you know, as close and have sort of human type of thinking and abilities, reinforcement learning is probably the branch of machine learning that might take us there much closer than we think versus sort of unsupervised, supervised learning. They're sort of quite down to earth. Now, in this course, again, we're going to be talking about supervised and unsupervised learning, and we're going to, you know, use them to solve business problems. Now, going even deeper into that topic, again, supervised learning, we're trying to predict class for a new data point that is previously not seen, but we do have examples. And there are two classes within supervised learning. There is a class of classification where you can just, I mean, there is a type of problem which is called classification types of algorithm, where you have to classify you know, items into classes, maybe into binary classes, yes or no, or maybe into, you know, several classes. And then the regression problem where you where you're given numerical values and you try to predict numerical value, like an example we talked with price. Then there is also ranking algorithms that are part of both classification and regression algorithms that gives us back sort of the rank. For example, I can calculate the, you know, the churn probability and then rank all the people by it and have a rank for a person. And unsupervised learning, there is like a lot of algorithms in there. There is, of course, you know, clustering or finding groups of points that are tightly connected to each other. I mean, tightly coupled more close to each other than with the rest. Then there are methods of what's called dimensionality reduction, you know, density estimation, anomaly detection. We're going to talk about them in turn when we, you know, discuss unsupervised learning as an example. So, sort of going a little bit upper in conceptual thinking, whenever you try to build model, whether it is supervised learning or unsupervised learning, it doesn't really matter. There are certain steps you need to do. And first step, you start with data understanding. You really need to know what the heck we give you, right? What data it is. You know, either need to read a company file or talk to people. You need to understand what those numbers really mean, right? Second, you need to do some data preparation. ETL, extract, transfer, load, process. In fact, if you ask any practicing data scientist, they will confess that, you know, easily, probably, you know, 60, 70, or sometimes even 80% of their time doing modeling is actually goes into data preparation, which is data cleaning, removing outliers, removing sort of empty spots, somehow transforming it, formatting it, et cetera, et cetera, et cetera. And in fact, you know, you work with different businesses. Every business will have its own format. Every business will have its own sort of description. Even inside the same business, different systems for the same customer will have different IDs, et cetera, et cetera, et cetera. So the skill of data preparation is is boring, but it's extremely important, right? You do need to know that. And in fact, you know, coming back to RAPIDMINER, it has quite good, so quite good methods to help you, right? And it has even, I think it's called Turbo Prep. It actually has almost automated way, or at least semi-automated way that allows you to read in data and understand it. I mean, it's extremely frustrating when you try to read in data and you realize, you know, somebody used, instead of commas, you know, semicolons, and so you have to redo everything again, or that's usually a pain. But this is a needed step, and you know, it's garbage in, garbage out. And so the time you spend on data preparation will pays off in the modeling. Then you build a model, whether it is, you know, supervised learning or unsupervised learning. In any case, there is a model that does something, and then you need to evaluate it. In supervised learning, there are very standard ways to evaluate the model quality. In unsupervised learning, there is sort of, you know, you can come up with the ways, and there are ways, but they're less standardized. But in any case, you need to evaluate the model to understand, you know, if it satisfies your KPIs. And finally, you need to prepare a model for deployment. You know, in fact, again, with the RAPIDMINER, there is even a way to sort of group your model together, all the steps, and, you know, prepare it for deployment. In any of those steps, when you see things goes wrong, you're kind of going back, right? You think you understand the data, you know, you prepare it, you start training the model doesn't work. Okay, you go back to data preparation, you try to evaluate model, you know, that you get bad scores, you go back to train it again, you know, it doesn't work, go to data preparation, or maybe to data understanding. Maybe you really didn't understand what the data were given to you. But this is sort of the pipeline you go through. And in fact, if you think about this for a second and reflect to the sort of RAPIDMINER workflow, that's why this sort of workflow models and this type of modeling software works really well for this type of problems, because this is a very natural mapping of the sort of consecutive steps you do to solve this problem into this type of software and solution. Now, going even step back up, and we're not going to do this in this course, but for your overall understanding, you know, if you were working for business and you would do this in business, you know, you'll start with collecting data, right? As we described, then you'll develop a solution, so machine learning, whatever solution you have. Then, and you know, again, right now we're going to be in this course, we're focusing with developing a solution, actually prototype, right? There it's sort of the product. Then you actually take this product and integrate with the client IT ecosystem, right? You need to connect to all the databases, you need to connect output to the right places. Then you need to create business process around it and you know, embed it in business process, or create new business process that didn't exist before. And finally, you need to scale it, right? You need to deploy it at scale, because any model you create will bring value to business only when it is scaled across the entire business. And so these are sort of the steps. If you go back to real life, that's what it takes to take the modeling and you know, put it in the real world. And so what we're going to do right now is we're going to just look into this second wheel here in this picture, because the data already has been collected for you, and you know, we're not going to be integrating the models into any system. In this course, you're going to be learning this sort of the second step. And just again, to have a big picture and understanding, you know, for a project in business to be successful, there are really three things that need it. So one is, yeah, it's really sort of good, you know, data and good algorithm and algorithmic solution. Second is the technology. So it's integration of the technology with the technology of the right choice of technology, and integration with the client technology and building the platform. And third is, of course, this integration into business. It's a business process, it's enablement, which means, you know, making sure the client can do those things, and it's change management, so changing the way the company operates. So we kind of went all the way from the sort of very top definition of data science down to looking into, okay, what sort of machine learning is and what type of machine learning algorithms exist. And now we came back to this understanding of what it takes for analytics project to be successful in real business settings. So that's pretty much it for today. This was, again, very introductory lecture. So we had a lot of generic terms, but I hope it gave you some idea what we're going to be doing and what this course is going to be about. Again, this course is not about programming. We're not going to be going very deep into properties of each algorithm. We're going to be using those algorithms. We'll need to understand what those algorithms can do. We need to understand how to control them, but we're not going to write each individual algorithm. We're going to be taking those algorithms like Lego blocks and connecting them together to solve business problems. And so that's the focus of this course. Now, next steps, what we're going to need from you guys first, get the Data Science for Business book and start reading, get yourself RAPIDMINER software and, start learning how to work with it and start playing with data. And we're going to have a seminar, which will start in a few minutes. And before that, we're done with the lecture. Questions, please. I know there has been a lot of stuff. I hope you're still there. So feel free now to ask questions. Turn on your cameras, turn on your mics.
Yes, hello.
Hello?
Yes.
Yeah. Okay. Sorry.
No,
So guys, turn on your camera when you ask questions, then that will kind of help others to be in line for asking questions. This is instead of like raising your arm, raising your hand, turning on the camera. Yes, please go ahead.
First, I would just like to ask, are you going to send us the presentations you just made today? And how do I get the textbook you just mentioned?
Predictable feature?
The Data Science for Business textbook, how do we get it?
Oh, the book. Oh,
Yes.
the book, we're going to try to help you find PDF for the book.
All right.
Yep.
And about the presentations, are you going to send the presentations after every lecture?
Yes.
Or?
Yes, I'm gonna send out the presentation. I'm gonna send it into the Telegram.
Okay, thank you.
Sure. Guys, any other questions? Okay. So if there is no more questions, yes. All right, I guess there is no questions. All right, if there is no questions, we are done. Thanks. I hope that worked out. Let us know in Telegram or emails if you feel we should somehow adjust this, to make it more interactive or make it more interesting. We're also learning how to run those lectures with lots of people online without any sort of physical presence. All right, thank you, and I'll see you in a week.
Thank you. Have a nice week. Thank you.